Alrighty then, given the root, write an equation of the possible polynomial, okay? So it's not for sure the exact equation because we don't know. There could be many polynomials with roots here, but we're going to write one equation that could be the polynomial here, a possible polynomial. So let's say you're given the roots at x equals 3, x equals -5, or x equals 4, and we're told the degree is 3. So the easiest way to do that would be to write these as factors, right? So write these as factors. So really all you do, let's just write this as y equals. You could write f of x if you want. It's really just going to be x minus 3 for this one. So we're looking at x equals 3. You basically do the opposite of the zero product property, and x minus 3. So if I added 3 to both sides, I'd get x equals 3, right? If this was set equal to 0. So that's how I write my factor. That's how the transition goes there. So if I've got x equals -5, it's going to be x plus 5, right? And lastly, we've got x equals 4, so this is going to be x minus 4. All right? Now, the degree 3. Well, it's a third degree polynomial because if I multiplied all three of these together, I'd get an x cubed term, and that x cubed term would be the biggest exponent. The cubed would be the biggest exponent. So at some point, if I wrote this in standard form, I'd get an x to the third power, and that would be the biggest exponent. So that's how I know it's going to be degree 3. All right? So if you look at all of these roots, they're all of multiplicity 1. They're actually simple roots. Okay, it means that none of their factors are squared or cubed or anything like that. They're all to the first power. Okay, that matches my degree. All right, the next one. So x equals 2, x equals -4, and my degree is now 4. That's going to be interesting. So I'm going to do the same thing. I got y equals x minus 2. Okay, and I'm going to have x equals, or x plus 4, right? So y equals x minus 2 times x plus 4, but the degree has to be 4. And so far, I've either got roots that I can't see, maybe I've got roots that are imaginary, right, complex roots, or maybe these two should be squared. So maybe this should be squared, because that would satisfy that, right? This would be a fourth degree polynomial at this point, which is really what I need. I wouldn't want them to start thinking of some imaginary or some complex roots here. I'm just going to assume that these both have multiplicity 2, right, to make sure my degree is 4. So if I'm writing a polynomial, remember it's just one possible polynomial, there's many of them. I could think of a number out front. I could think of like 7, and that wouldn't change anything. So my a out front, we're just assuming that it's going to be 1, because I'm trying to get the easiest or the simplest polynomial, right? So now both of these, this root at 2 has multiplicity 2. This root at -4 has multiplicity 2 because their factors are each individually squared. So this x minus 2 is squared. All right, let's look at one more example that kind of trips people up. It's really the same idea. We've got x equals 1/2, x equals -1, and x equals 7. We're saying the degree is 3. So all three of these must have multiplicity 1, right? So x equals 1/2. The mistake that I see people do is just write this, x minus 1/2. All right. Now that's not really helpful for us. The factor really would be, and I'm going to just write a little example here. If I got x equals 1/2, right? If I'm undoing the zero product property, I would want to multiply by the denominator. So multiply both sides times 2, right? When I do that, I get this. I get 2x equals 1. All right, well then how would I get rid of the 1, subtract 1? So I'd really be left with 2x minus 1 equals 0. And that's what I want my factor to be. So I really want y equals 2x minus 1. And you can see now, if I worked backwards, that's how I would get my 1/2. So one factor is going to be 2x minus 1, all right? Not just x minus 1/2. And the other one's going to be x plus 1 from here. And then my last one is going to be x minus 7. All right, works with my degree. The reason I want to do this is because later on, when we have specific ones, we're going to be dividing, we're going to be using some multiplication in order to get our polynomial. And you want to be looking at the factor like this. That will help you out in the long run. And it'll work with any of them. You just kind of have to remember, hey, if I've got a fraction as a root, I need to multiply times the denominator first, then subtract the numerator, which is exactly what we did here to get this root. All right, good luck.